Many of the disasters that we respond to result in damaged homes. With our smart aid, we aim to not only help the people affected rebuild their homes, but build them back better, more resilient.
This is a model of a typical village house in the Asia Pacific region.
The model is based on this house seen under construction in the Philippines.
This model has been built using round timber poles and lashing, but there are similar houses built with square section timber. The problem with this type of construction is that in winds the whole house moves about, and this can loosen the joints. So when a strong wind comes, the whole house flexes and the roofing sheets and walls tend to get lost. The joints fail, and in very strong wind conditions, because the house isn't very well connected to the ground with strong foundations, the whole structure can start to lift. This Built Back Better house has diagonal bracing in the walls and the roof. This, together with foundations into concrete, means the house doesn't flex in the wind. This stops the joints wearing and becoming loose and makes the house much more resistant to the major typhoons. Also, the whole structure is tied down to the foundations with either steel strapping or, in this case, strong wire that holds the roof right down to the foundation.
What do we mean by resilience? Well, for us, it means rebuilding as many homes as possible, stronger than before, for around $1,000 and only taking a few weeks. Not building just a few typhoon-proof houses costing over $10,000 each and take many months.
This represents the side of a typical village house with the timber upright sat on a flat concrete foundation. The problem with this foundation and upright is that in a strong wind it doesn't stop the upright moving and stressing the structure. It doesn't stop the whole structure being pushed along. In a very strong storm, it doesn't prevent uplift, as the building might be lifted up or toppled over. This uses a foundation that's cast into a hole in the ground with these steel straps cast into the concrete, and then the timber is nailed to the straps. This stops the risk of the foundation sliding. It also stops uplift, but there is still some movement. Rather than use steel straps like this to hold the upright down, it will be stronger if you can get some angled steel. It will make the whole thing much stiffer. With this foundation, the upright is actually cast into the concrete when you make the foundation. This makes the whole thing very strong and prevents uplift, tilting and sideways movement. This shows a basic construction of the joint between the upright and the roof. The two components of the roof are nailed together, and this is held on top of this top plate with nails nailed in diagonally. This can be very weak. This joint uses a steel strap like this, a thin strap which can be nailed into the various members and holds everything much more securely. If there is no steel strap available, you can always use wire, such as fencing wire. This holds everything together. An even stronger result can be achieved if you take the upright up so you are nailing the roof timbers directly to the upright. This holds the roof down much more firmly. I'd like to show how bracing can make a simple frame much stronger. To do that, I've made 4 of these square frames, but I've made them so they actually move a lot. And what I'm going to do is put a bracing system in to make them stiff and stop movement at the joints. The first technique is just to use one diagonal brace. Here's a piece of wood that I've cut to fit, and once I secure it, it will hold the frame steady. Once you've nailed the brace firmly in place, this frame is now rigid, and even though the joints have been made loose, they now will not move. I'm going to brace this frame with these thin metal straps. The straps can be nailed tightly in place, and then this frame again is rigid and will not move. If you can't get hold of steel straps, you can use wire, but again, as with the steel straps, you must cross brace. You can see the wire here, and it's held on with a couple of wire staples, or you can wind the wire around a nail or a screw. So here is the finished wire braced structure. Again, it is very stiff. It stops these loose joints moving and keeps the structure strong. Another way to brace one of these loose frames is to use a thin, flat piece of material. Plywood, metal, any flat material will do. And what we are going to do is fix this all around the frame. Once this is nailed in place all around the edge, again we have a very rigid frame that will not move. These are some of the standard fixings. This is a wire nail. It can do a good job if used properly, but it can come out quite easily. This is a bit better. This is called a twisted shank nail, and there's a twist there that means that it grips the wood better. And the best is some sort of screw. This is a standard straight screw, and this is a roofing screw to hold material like corrugated iron sheet down. If you have only got wire nails, when you are nailing timber together, don't nail straight down like this, as it makes the nails too easy to pull out. But nail at an angle so the two nails combined lock into the wood. This Built Back Better house has diagonal bracing in the walls and the roof. This, together with foundations into concrete, means the house doesn't flex in the wind. This stops the joints wearing and becoming loose and makes the house much more resistant to the major typhoons. Also, the whole structure is tied down to the foundations with either steel strapping or, in this case, strong wire that holds the roof right down to the foundation.